Okay, so we're expanding and condensing today, but this is where we have some of the properties that we're going to use. One of the properties that's going to get used a lot in what we have today is, well, not necessarily a lot, but some. Just don't forget that if you have log base b of b, if those match, it just equals 1. That's going to help you out on some of them. And then if log base b of b to the k equals k, right? You just get the exponent. Do you understand why that happens? What happens to this exponent? What can I do with it when this is a log? I can pull it out in the front, right? So then I would have k times log base b of b. Well, log base b of b is 1. So basically you end up with k times 1 and then it's just k. Okay, so that's why that works out that way. So if you get confused about that, you can always pull that out to the front like it's supposed to go and then use that property and it's the same thing. Or this just gets you there directly. All right, so today, adding a few others to the review, and this is going on page 88. So again, once again, m, b, and n have to be, or b, m, and n have to be positive numbers such that b is not equal to 1. And then these properties, again, should be all of a review, because you did it in Algebra 2. But we have the product property, quotient property, power property, which we just talked about, and change of base. Okay, so if I have log base b, or a log of any base, and I have two things multiplied together, I can separate that out into adding two separate logs. And the converse of that works as well. If I'm adding two and they have the same base, then I can condense them, because we're going to be expanding and condensing, like which direction it goes. And then subtraction is just division, okay? Power property, change of base here. If I need to change this base to match something else, then my new base is A. Whatever was out in front of the log comes in the numerator, and then the old base goes to the denominator every time. And then that's just, your new base has to match in the numerator and the denominator. So it's a pretty simple thing to do. You just have to be able to remember the order and what you're doing with it. Okay? All right, so then at the bottom, just kind of an explanation of the expanding and condensing. So when you expand them, you break down a single logarithm into the sum and or difference of two or more logarithms with the same base as the original expression. There is no multiplication or division left in the expression. Okay, so when you expand it, it all becomes the sum or difference. All the logs have to have the same base, and there's no multiplication or division left. That's how you know you're done expanding. Yeah, I think that concept of expanding probably makes sense. You're making it larger. But then condensing, so when you condense it, it's the reverse, obviously, and you end up with a single logarithm. When it is condensed, there is no addition or subtraction left in the expression when it's condensed. Okay. So if it's condensed all the way, there's no addition and subtraction. If it's expanded all the way, there's no multiplication or division. Okay, we all good on that? Because you could always do something halfway. You got to make sure you do it all the way. Alrighty, let's try this first one then. So I have log base 3 of 9x squared y to the 5th. So how many things are being multiplied together there? 3, right? You got the 9, the x squared, and the y to the 5th. So I'm going to expand that, and when I have the product property, that means the multiplication turns into addition of separate logs. So this will give me log base 3 of 9 plus log base 3 of x squared plus log base 3 of y to the 5th. Okay? But I'm not done, right? You have to clean up anything you have. You can't leave the exponents. That's why we have the power rule there. And we also, that very first log base 3 of 9, I can actually simplify farther, right? That's why we did what we did yesterday. So I'm going to take this right here, kind of do it up here a little separately. And this is an expression. I want to simplify it. So the way we did it yesterday is that we took the log base 3 of 9, we're going to set it equal to k. This is why I didn't use x yesterday, because now there's x's in here, and I didn't want that to be confusing. You're way less likely to have a k in there. So to rewrite this as an exponential, what would it look like? 3 to the k equals 9. So that means that 3 to the k equals 3 squared. So k equals 2. And k represents this right here. So now this gets replaced with 2, right? We're going to substitute it in there. Does that make sense to you? So this becomes 2 because we just simplified it. Plus. Now, since that's x, I'm not going to get an actual number out of it, but this 2 right here that is an exponent, it comes down in front of this log, and this 5 is going to come down in front of this log here. So I get 2 plus 2 log base 3 of x plus 5 log base 3 of y. So now I have no multiplication left in the logs. Obviously there's multiplication here. That multiplication is okay. But in here, no powers or multiplication there. Everything is addition or subtraction, and we're good. Any questions about that at all? All right. Let's do the next one together, and then I'm going to have you do one. All right, so this is log base 2. Now I have division here. I have something here. If you have some sort of expression that can be factored, you need to factor it. Okay? Can I factor that? No. If it was x squared minus 4, could I factor it? Yes, but this way I can't factor it, so I'm going to leave it. But if you can factor it, you need to factor it because it's going to separate it out more. Does that make sense to you? So make sure you pay attention to that because there are a couple of them where you're going to need to do that. Okay, so basically this is just one. I have to leave this as one term because I can't split it into anything, and I have this as one term. So when we divide, that is going to give me log base 2 of 128. And division makes this what? Subtraction. Minus log base 2 of x squared plus 4. Okay, and I need that in parentheses so I know that it's like all one thing there. So this one looks like I could simplify this number out, right? So I'm going to take this up here and do it separately. So log base 2 of 128 equals k. So 2 to the k power is 128. So that means that I get 2 to the k power equals 2 to the something. If you just know it. What is it? Is it 7 or 8? It's like 1. So 2 times 2 is 4. Then I get 8, 16, 32, 64, 128, 7. Yeah. I have to count on my fingers or make little hash marks or I'll lose count. But yeah, 7. So then k equals 7. So that's where this is going to come from here. So I get 7 minus. Now I have an exponent here. Does this exponent get to come out in front here? No. And do I get to split this up into 2 additions or anything? No. Okay, that all has to stay there, so I have to just leave that as log base 2 of x squared plus 4. Sometimes there's not much you can do. If you were able to factor it, like let's say that it was x squared minus 4, then I'd have x minus 2x plus 2 right here, and so then I'd have 2 things multiplied together, so then that would separate them out into 2 logs. Does that make sense? That's why you need to make sure you can factor it, because I can split it up some more. Anything else? Any other questions? All right, I want y'all to do number 3. Work on number 3 on your own. Let me get you started on this one because I want to talk about the adding and subtracting part here. Because we have some divisions, that means I've got some subtraction. So I'm going to start with log base 3 of x squared, and then it's divided by 81, y to the 4th. So it's going to be minus log base 3 of 81. Now 81 is being multiplied times y to the 4th, right? So is this right here going to be addition or subtraction? It's subtraction if I don't have any parentheses. Okay, because I want you to think about what this is. So let's just pause on this. Let's just think about how this would be written, like if I wrote it out elementary school-wise as far as multiplication and subtraction, or multiplication division rather. So this is x squared divided by, right, 81. Now, if I do times y to the 4th, then my order of operations says that's x squared divided by 81. I get my answer, and then I multiply it by y to the 4th. Is that what's happening there? No, so that's why here, if I put addition, that's basically what I'm saying. Now, if I put parentheses here like this, then is that what's happening? And then, so I could put parentheses there, but then I'd end up having to distribute. So what's really happening there is I have x squared divided by 81 divided by y to the fourth. Because even if I did that and I had a fraction and a fraction, wouldn't it end up like that after I simplified it? You with me on that? So don't let that whole, what am I doing? I'm still dividing by the rest of this. So this is log base 3 of x squared divided by 81 and divided by y to the fourth. So if I'm not going to put any parentheses there, then that's another minus log base 3 of y to the fourth. Does that make sense to you? Because if you did put minus and then you put parentheses and then you put addition here, that's fine. But in the end, you end up distributing it anyway. So whichever way makes more sense to you to make sure you get your signs right, you're all good. Okay? We okay with all that? All right. So now that I'm here, this log base 3 of x squared, what happens to the 2? Comes out in the front. So I get 2 times log base 3 of x minus, now am I going to be able to simplify this sum? Yes, so I'm going to take this up here. So that's going to give me 3 to the k equals 81. So 3 to the k power equals 3 to the fourth, okay, which means k equals 4. So this is just minus 4 minus, then this 4 comes out in front, 4 log base 3 of y. Everybody okay with that? If there wasn't a parentheses there, well, these parentheses really are just telling you, these parentheses really aren't even necessary since everything's multiplication. It's more about how you wrote it out. So if I could have written out log base 3 of x squared minus log base 3 of 81 plus log base 3 of y to the fourth. But if I do that, these parentheses have to be here because I'm subtracting all of that, right? And then when I distribute that negative sign, I end up there. So I kind of just skipped this step. Well, it's not really skipping a step. It's just depending on how you look at what's happening. But that's where parentheses would matter. But you're not going to leave them in there in the end anyway. So if you can understand how to do it from the beginning, you won't have to do that step. Does that make sense? We're all good with that? All right, so I want you to try this next one on your own, and then I'll let somebody help me through it. Unless you had any questions. Were there any questions? Okay, so I'm going to get log, and if there's no base, what is it? 10. Okay, so the log of 100, and then all these three things up here in the numerator are all being multiplied. And I have 3 terms being multiplied together, so I need 3 different logs for the numerator. So log of 100 plus log of x plus log, and I can put square root of y here, but I'm going to need the fractional exponents eventually anyway, so I'm going to go ahead and just make that y to the 1/2. And then, so these are all multiplied, that's all the numerators. So I'm going to subtract what's in the denominator, and so that's log 10 to the 1/3 power. Everybody okay with all that? I'm sure where everything came from. Okay, so then I'm going to take this. I'm doing it right there, so I don't lose you there. So the base is 10. So 10 to the k is equal to 100. So what does k equal? 2, right? So this is 2 plus log of x plus, what happens to this 1/2? Comes out in the front, right? 1/2 log of y. Now, I could do the same thing I did over here, but what is the base of this even though we don't see it? 10. And if you have the base of the log and the base of this exponential expression right here, they're the same, then what is the answer to this? 1/3. Log base 10 of 10 to the 1/3 is just 1/3. Okay? So that's minus 1/3. If you need to do the work, you can do the work, but you just don't need to. All right, so now I need to simplify it a little bit more because I have the 2 and the negative 1/3. So this would, as a fraction, be 6/3, right? And then 6/3 minus 1/3 is 5/3. So 5/3 plus log of x plus 1/2 log of y. Any questions about that? We all good? Yes, sir. It does not matter what order you put them in. That's a good question. So how was yours different? I'm just curious. Put the number at the end. Okay, that's fine. Because I mean, it doesn't matter, but I always wonder when people like totally mix these up. Why would you do that? That makes it more confusing to me. But putting that at the end, I can totally understand. All right. Any questions? Okay. So condensing, it's a little bit easier here. So the first thing we have to do is, first of all, make sure all of our bases are the same. Okay. All the bases are the same. That's good. I got to see if I have anything out in front here that I need to change back into an exponent, and I don't. So I have log base 3 of x, log base 3 of y, and log base 3 of 5. So overall, it's just going to be log base 3. Sometimes you can do all this in one step. Sometimes it's going to take you more than one step. But I have x minus y, which means that's going to turn into division, right? So x over y. And then this is addition, so it's being multiplied by 5. So where's the 5 go? Well, it goes in the numerator, because those are being multiplied. So it's really just log base 3 of 5x over y. You could put x times 5, but I just think that's weird. I don't know. So I think it's one of those things that was drilled into my brain. I don't think it's wrong. It's just not right. Because this is what's in the denominator. Because again, if I had, so what is happening here with this subtraction, so this becomes division, right? So if I'm going to divide by something and then multiply, so if it's like, let's see, x, and then I'm going to divide by y, then I'm going to multiply by 5, right? So your order of operations says that's x divided by y, oh my gosh, by y, times 5. So that becomes your 5x over y. Does that make sense? So without writing all that out, that's just kind of what happens with the order of operation. If you need to write that out to make it make sense to you, that's okay. It's just not, you don't need to. Okay. We're good? Yes? All right. So here's one with those parentheses, right? You don't have to distribute, but what this is telling you is that all of this here goes where? In the bottom. These two things are being multiplied together, but it's all being divided into this. So this is just going to be log base 2 of x. The subtraction means we're dividing by all of that. And so those two things get multiplied in the denominator. This is the case where it would look like that. Okay. So do you see the difference between the two? That's why it's like that. One of each one there. All right, we'll do the last two together just for the interest of time. So now on these, I have some numbers in front of the logs, which means this 3 becomes the exponent for the 2, right? The 2 becomes the exponent for the x. The 6 becomes the exponent for the y. And the 2 becomes the exponent for the 5. So this is going to give me log base 4. So this is positive, which means it starts off in the numerator. It's going to be 2 to the 3rd power. Plus, which means it's multiplied. This becomes x squared. And then subtraction, so there's in your denominator, y to the 6th. Where does 5 squared go? In the denominator. Now my intention when I started this problem, I don't know, and then I didn't do it, was to rewrite this before we did that. You don't necessarily have to, but I didn't want to lose anybody. So what I could have done and what I really intended to do was log base 4 of 2 cubed plus log base 4 of x squared minus log base 4 of y to the 6th minus log base 4 of 5 squared. You don't necessarily have to do that step, especially since it's a review. If I was teaching all this from scratch, I'd make you do that. You might need to do that if it's been a while, because I know it's a review. Just because it's a review doesn't mean that y'all spent 6 weeks on it. It could mean that you spent a day. So depending on your comfort level, you may not want to jump from here to here because you may totally mess things up, right? It may be better to go ahead and fix them with the exponents and then do it. Totally up to you. Right? That's what I intended to write, and then, I don't know, my brain does its own thing sometimes. But even here, I still need to clean it up some. I need to reduce stuff if I can. I can't reduce anything, but I also can't leave this 2 cubed. So what is 2 cubed? 8. So log base 4 of 8 x squared over 25 y to the 6th. There's my final answer. Everybody okay with that? And log base 4 of 2 cubed isn't something that you could simplify. You know, you couldn't get matching bases and, actually, well, you could get matching bases there, but we don't fix that for whatever reason. But there are some that when you can't simplify them like we did on the other one, and it's okay. All right, so here is this one. Again, interest of time. Okay, I'll give you all a minute to get started on that one. Go ahead on this one because it's a lot longer. Rewrite it like this before you get started. I think that would be better for you. And then I'm going to pass out the homework while you do that, and then I'll walk you through it. Sorry. Okay, what is 16 to the 1/2 power? 4, right? So this really is just going to become 4. And what is 4 squared? 16. So, log base 3 of 4. And minus, then this becomes log base 3 of 16. And then plus log base 3 of x to the 5th minus log base 3 of x to the 4th plus log base 3 of what? 8. Okay, so I would rewrite that. I know some of you, if there's a lot, you just want to like skip steps and not do all that, and just be careful that you're not making mistakes. So this is positive, which means it's going to start off in the numerator. All of my bases are the same. That's good. So I get log base 3. In the numerator, I have 4. Where does the 16 go? The denominator. Where does the x to the 5th go? The numerator, because it's addition, right? X to the 4th goes where? Denominator, because it's negative. The 8 goes in the numerator. Okay, everybody understand where everything came from? Okay, so then I can reduce this sum, right? I can reduce, and 8 goes into 16 twice. And then I can reduce the 4 and the 2, so this just becomes 2. Can I reduce the x's? Yes, so in the end I get log base 3 of what? 2x. And that's why we condense, because you can make that, take that madness and turn it into that right there. If it helps you to multiply it out and then reduce it, you can do that too. But any questions about where anything came from? Okay, so let me tell you what our plan is for the work. Now today, this isn't actually what we're supposed to do today. I had another assignment that was the same material as yesterday, so basically there wasn't going to be any notes, you were just going to work on that. But I felt like it would be better for you to have some class time to work on these. So tomorrow, I'm not going to do any notes or anything. You are going to have time to work on this, but you're also going to have another one of the expressions like I gave you yesterday. So just know that that's not the only thing that you have. And you can decide which one you want to work on. My suggestion to you is that you get started on this and figure out maybe where you do have some questions, because there's some pretty good ones on there. They're not impossible. They're not crazy hard. They're going to make you think a little bit. And that's why I wanted you to have some time in class to work on them, to be able to ask some questions and talk to each other and that sort of stuff. But I would suggest that you actually get started on it so that you can try some out and see if you have any questions. All right? Any questions for me right now? We do have a quiz tomorrow. Thank you for saying that. I meant to say that at the beginning. And Is it this one? Okay. So yeah, your quiz tomorrow, it's probably going to be shorter than this one. If I can give them to you more often, they can be a whole lot shorter. It's going to just be, I'm going to give you a couple of the rewriting and simplifying logs. Not crazy hard ones. Okay. But what to do tomorrow, you have a little quiz over that. Okay. Alrighty. Have a great day. I will see you tomorrow. Get started on that.